everyone, Mrs. Greenman here. I'm going to talk to you today about how to calculate the volume and surface area of spheres. First of all, take a look at the definition. A sphere is the set of all points in space equidistant from a given point. This point is called the center of the sphere. A radius of a sphere is a segment from the center to a point on the sphere. So if you look, this is an example of a sphere. C is the center, and this is one of the radii of our sphere. Some vocabulary here to be familiar with when we're talking about spheres. We have a radius of a sphere, which we just talked about, and in this example here, AC is one radii, AB is another radii of our sphere, and AF based off of the examples here. So let's write that down. We have AC, we have AB, and AF. Okay. A chord is a segment whose endpoints are on the sphere. So in this example, BC is a chord and DE is a chord. So let's write that down, DE and BC. The diameter of a sphere is a chord that contains the sphere's center. So in that case here, this would be BC. We're going to talk about something called the great circle. And the great circle is a section of a sphere that has the same diameter as the sphere. So if you imagine a plane here, this orange plane, if this plane were to come along and it intersects a sphere, and if that plane contains the center of the circle, it's called the great circle of the sphere. So in our case here, our great circle would be, in our example, would be circle A here. A hemisphere is half of a sphere. Okay, so there's some vocabulary to be familiar with about spheres. We're going to talk now about the surface area of a sphere. So imagine what you're doing if you had, let's say, a basketball or a baseball and you wanted to wrap that up as a present for someone. The number of square units that will exactly cover the surface of the sphere is the surface area. The formula for surface area of a sphere, surface area is equal to 4 pi r squared. So to find the surface area, you need to know your radius of your sphere. So let's look at example 1. We're going to start basic. Here we're asked to find the surface area. We know based off of this example, we have a sphere and we have the radius of 8. So we're just going to simply substitute 8 into the formula. So we have 4 times pi times 8 squared, okay? And you can simplify this, you end up getting 256 pi. Now, when you enter this in your calculator, you're going to do 256 times pi, not just times 3.14, and let's round for now to the nearest tenth. You should get 804.2. Now, you want to make sure to use your units. This is inches, and since we're talking about area, we're going to be talking about square units. Okay, so that's a basic example. Let's move on to example 2. Here we want to find the surface area of the sphere, and we know the circumference of the great circle. So what does that give us? So I can't just go ahead and substitute because for surface area, we need 4 pi r squared. So I don't know my radius, but I do know that my circumference is 12 pi. And we know that the formula for circumference of a circle is 2 pi r. So if we set these things equal, we have 12 pi equals 2 pi r, and what we're looking for is r, the radius. So if we divide both sides by 2 pi, we end up getting 6. So the radius of the sphere is 6. We can use this information in our equation. So now we have, for our surface area of our sphere, we have 4 pi times 6 squared, which becomes 144 pi. Just multiplying 36 times 4. And then when you use your calculator, you get 452.4 feet squared. Okay? So surface area, we're talking about covering the surface. Area, we're talking about square units. The next topic we're going to talk about is volume of a sphere. Okay, so for volume, that's the number of cubic units used to fill up a sphere. And the formula for volume of a sphere is V equals 4/3 pi r cubed. Students often get confused. This one has a cube, the surface area formula has squared. So I try to remember that area is square units, so r squared is in the surface area formula, and volume is cube units, so we have r cubed in this formula, if that helps you remember. So we're going to start off basic. We want to find the volume of the soccer ball. We know that the radius is 4.5. So we're going to just simply substitute. We have 4/3 times pi times 4.5 cubed. Now you can go ahead and put all of this in your calculator at once. Just make sure to input the 4/3 in parentheses as a fraction. And remember on your calculator to raise something to the third power. On the graphing calculators you use that caret, that up arrow, and to the power of 3. So when you do that, you should get the volume of this soccer ball is 381.7 inches cubed. Okay? So remember your units. For these problems, we're going to be rounding to the nearest tenth unless otherwise specified. Okay, so let's take a look at example 3 now. So for example 3, we are asked, we know that the surface area, so we know that it's 64 pi units squared to cover the surface of a sphere, and we're asked to find the volume. So when I read this problem, I'm thinking, okay, volume. I need my formula, which is 4/3 pi r cubed. Well, this isn't so easy because they didn't give me my radius. I can't just simply substitute, but I do know that my surface area is equal to 64 pi. I also know that the formula for surface area of a sphere is 4 pi r squared. Right? So if I set my formula for surface area equal to the surface area in this problem, we have 4 pi r squared equals 64 pi. Now, simply what we're going to do is we're going to try to solve for r. So if we isolate the r squared, divide both sides by 4 pi, we end up getting that r squared is equal to 16. To undo something being squared, we take the square root of both sides, so r equals 4. So the radius of our sphere is 4. Now we can take this information and substitute back into our equation. So for volume, we have 4/3 times pi times 4 cubed. Simply inputting that into your calculator, making sure to put the 4/3 in parentheses and using the pi key and not 3.14, you're going to get the volume is 268.1. Now they didn't give us units here, so we're going to just say units cubed. Okay. And the last example that we're going to go through together before you guys move on to the practice is example 4. It says the cube has a volume of 1,728 centimeters cubed. Find the volume of the inscribed sphere, so the sphere that's inside the cube, and the volume of the empty space. So as you can see here, we have a cube and we have a sphere inside, but the sphere doesn't take up the whole space inside the cube. So our goal is to find the volume of the sphere, and we need to also find the volume of the empty space. So we know the volume of the cube is 1,728. So let's write that down here. We have the volume of the cube, which is 1,728, okay? We know that volume of a cube is length times width times height, but in a cube, all sides are the same. So basically, we're multiplying the same thing times itself 3 times to get 1728. In other words, x cubed, or side cubed, is equal to 1728. So if we take the cube root, so on your calculator you can take the cube root. On graphing calculators you're going to hit math, and then the fourth option gives you the cube root. So if we do the cube root of 1728, we get that x equals 12. So that's the side of our cube. All the sides are 12 units. So if you think about it, if this side, for example, is 12, that means this whole thing here is 12. So if we're looking for the volume of a of a sphere for our next part, we want to find the volume of the sphere, we need to know the formula, which is 4/3 pi r cubed. So we need to know our radius. So our diameter here is 12, so our radius would be 6. So our volume of our sphere would be 4/3 pi and then 6 cubed. So when we do that, leaving it in terms of pi, we get 288 pi. So that's the first part. The first part of the problem is we wanted to find the volume of the sphere. So we can write down here that the volume of the sphere is 288 pi units centimeters. We know the unit, centimeters cubed. Okay, so that's the first thing that we needed to answer. Okay, the next part that we needed to answer is we needed to find the area, the volume of the empty space. So if I know the volume of the cube and I know the volume of the sphere, to find the volume of the empty space, I'm going to take the volume of the cube, which is 1728, minus the volume of the sphere, and that's going to give me the volume of my empty space. Rounding that to the nearest tenth, I get 823.2 centimeters cubed. And this here is the volume of the empty space between the cube and the sphere. I hope you enjoyed the lesson. What you're going to do now is you're going to work on the 6 practice problems. Some of them are a little bit tricky, and then you can reference the key to check the work. Bye.